Hi everyone, welcome to In 5 Minutes. In this video we are going to solve the sum that is based on radix to DIF FFT. Let us have a look on the question. The question is, obtain the DFT of the sequence, that is, the first four terms are half and rest all are 0. We have to use the decimation in frequency FFT algorithm. Here, as the capital N, that is the period, is 8, that is the number of terms. So first let us see what are the values of twiddle factor. The values of the twiddle factor will be w8 raised to 0, that is e raised to 0, again 1, w8 raised to 1, that is e raised to minus j pi by 4, that is 0.707 minus j 0.707. w8 raised to 2 is equivalent to e raised to minus j pi by 2, that is minus j, and w8 raised to 3 is equivalently minus 0.707 minus j 0.707. Now we will go by output of the stages. So we'll three stages of decimation here. Now let us see the output of the first stage, but first let us have a look on the flow graph. So now we will draw the first stage, but first we will write down the inputs. The inputs will be in normal order, that will be x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6, and finally x of 7. Now we will draw the flow graph. Compared to DIT, in DIF the flow graph will be in the reverse order, that is, the third stage flow graph of DIT will be the first stage flow graph of DIF. So let us have a look on it. For the first stage, the x0 will be combined with this stage, that is of x4, and finally it goes on like this. And again we will mark the directions, that will be the flow. And also remember that after the butterfly ends, there should be the marking for -1, that is the multiplying factor. Another major difference is of the twiddle factor. First we will write the -1, as this is a multiplying factor. For the twiddle factor, it comes after the summation sign, that is this part, w8 raised to 0, w8 raised to 1, w8 raised to 2, and w8 raised to 3. So it is like after the addition, then it is multiplied by the twiddle factor. This is the first stage of decimation. Let us say for the output of the first stage will be g of 0, g of 1, g of 2, g of 3, g of 4, g of 5, g of 6, and g of 7. Now we will compute the first stage. So the output of stage 1 will be, let us specify the stages, that is the stage 1, stage 2, and stage 3, and here will be the final output. But remember, the final output will be in bit reversed order, that is x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3, and x of 7, like in DIT, which is a input for DIT. So this is the third stage of decimation.